Question 6. A car of mass 1,800 kilograms is towing a trailer of mass 300 kilograms up a straight road inclined at an angle of alpha to the horizontal, where sine alpha is equal to 0.05. The car and the trailer are connected by a tow bar which is light and rigid and is parallel to the road. There is a resistance force of 800 newtons acting on the car and a resistance force of F acting on the trailer. The driving force of the car's engine is 3,000 newtons. Part 8 is given that F is 100. Find the acceleration of the car and the tension in the tow bar. Again, we are going to draw a diagram here, and then we put all the forces that are acting on these two particles. So if this is my inclined plane, and then I have, maybe this is the horizontal, then we have the angle here is alpha. So if this is the trailer and then connected to the car, it's just a sketch. There is even no mark for it, but it helps you to interpret. So this car here, and this is the trailer. The car has a driving force of 3,000 newtons. Now, there is a resistance force here. I mean, we call it the normal reaction. And the normal reaction, the normal reactions here are going to be different. The one on the trailer and the one on the car, because they don't have the same mass, okay? Then here we have the mg cosine. So this is 1800 g, then cosine of the angle, okay? And the mass of the trailer is 300. So that means here I will have 300 g cosine of alpha. Then when you resolve horizontally to this plane, then you will have 300 g sine of alpha. Then also this one here will have 1800 g sine of alpha. Okay, same angle here because they are on the same plane. And then there is a resistance force of 800 acting on the car. So I'll put here the 800 newtons. And then on the trailer, we are seeing it is what? It is F here. Okay, so it is F. But F has been given as 100. Okay, so it has been given as 100. Now, I can actually just put it as 100 newtons here. Now, find the acceleration. So what we need to do is, there is also the tension in the tow bar here. So there is a tension. This tension is the one that pulls the car behind, but it is the same tension that actually pulls the trailer forward. Okay? Now, we are going to look at the forces that are acting on the car individually. Then we also look at the ones that are acting on the trailer. So we use F, which is equal to MA. Okay? Now, the system is going this other side. So we have this driving force for the car, so 3,000 minus the resisting forces here. We have this one, and the tension, okay? Just the car, forget about this one here. So we shall have tension, then there is 800, then there is 1800 g sine of alpha. Then we equate this one to the mass of the car, which is 1,800, and then A. Okay? Then we go to the trailer now. Forces acting on the trailer. So we have the tension here that is taking it forward. Then minus, there is this tension here. I mean resistance, that is 100. Then minus 300 g sine of alpha. Okay? Which is equal to 300 A. Because its mass is 300. Now, we solve these two equations simultaneously. We know sine of alpha, which is actually 0.05. They gave it as 0.05. We also know g as 10. So that means the only two unknowns we have are the tension and the acceleration. So what I can just do to eliminate the tension, I'll just add these two equations, because this one is negative and this one is positive. When you add them together, it just disappears. Okay. Now we shall have 3,000 minus this 800 minus this one here is going to be 1800 times 10 times 0.05. Then there is minus 100. Then minus here, this one is going to be 300 times 10 times 0.05. And then when we add this to that, it will give us 2100. Okay. So meaning acceleration is going to be equal to whatever we get here, then divide by this. Okay. So what do we get here? 3,000 minus 800 minus 1800, 0, because times 10, then 0.05, then minus 100 minus 300 into, of course, 10 times 0.05. So we get 1050. So 1050, then divide by 2100. That's like a half. Divide by 2100, a half. So acceleration is equal to 0.5 meters per second squared. That is that for acceleration. Then for us to get the tension, I can use any of the two equations. So if I use this one here, we shall have 300 times the acceleration, which is 0.5, then add on the 100. Also add on this one here, 300 times 10 times 0.05. So what will be the tension in the tau bar? 300 into 0.5, then plus 100, then plus 300 times 10 times 0.05. So that is 400, okay? 400 newtons. That is that. Part B, it is given instead that the total work done against F in moving a distance of 50 meters up the road is 600 joules. The speed of the car at the start of the 50 meters is 20 meters per second. Use an energy method to find the speed of the car at the end of 50 meters. I'm again going to draw something small here, the diagram. So we are having these two particles at the start here. So the trailer, then we have the car. Okay. So then they move up to this point here. So the car is now here. Then we also have the trailer. So they have moved a distance of 50 meters. Okay. That distance is 50 meters. Then I'm going to put the resistance forces. So there is F on the trailer, and then there is 800 here. Okay, on the car, 800 newtons, and then this F newtons. Okay. Now, by the time, first of all, when they are starting here, the speed, the speed here is, let me first shift this one, all of it, a little bit here. So the speed is 20, okay? 20 meters per second. So if it is 20 meters per second, that is our U here, 20 meters per second. So at the start here, there is kinetic energy because of this speed. Now there is no potential energy because of because this is on the horizontal ground. Now, by the time they reach here, when they have traveled 50 meters, okay? When they have traveled 50 meters, this simply implies that there is a vertical, there is a vertical height that has been generated, this one here that I'm putting. So we need to know the h here. Okay, now when you use a right angled triangle, this is 50 meters, the one that we are having here, and then this is alpha, this is h, this is opposite and hypotenuse. How are they connected? That is by sine. So sine alpha is equal to the opposite h out of the hypotenuse 50. So when I cross multiply, then h becomes 50 sine alpha. Okay, I keep that there. Now, when these particles reach here, they will be moving with a certain speed. We don't know. And for that case, there will be potential, kinetic energy. And since there is generation of this vertical height, then there will be potential energy. Okay, so what are we therefore going to have? This is the work energy principle that you need to know. If you have been following me, you must be in position to know this. Work done by the driving force, work done by the driving force minus work done against resistance, work done against resistance is equal to change in mechanical energy. And mechanical energy is equal to kinetic energy plus the potential energy. Now, work done by the driving force. The driving force of this car was given here as 3,000. Okay? Remember, all of these parts are on this question here. So the driving force is this one here, 3,000. So we have here 3,000. Then, of course, work done is force times the distance. The distance is 50. So times 50. Then minus work done against resistance. The total resistance force is going to be the 6,000. By the way, they said in moving a distance of this, it is given that the total work done against F in moving a distance of this is 6,000 joules. So we have for only F, that means when you get F times the 50, you are getting the 6,000. So we have 6,000 here. Then plus, there is also work done against this 800. So 800, then we shall multiply it by 50. Okay? I'm not multiplying this one by 50 because it is already the work done against the F. Hope I'm clear there. Then this one is equal to the change in mechanical energy. You get mechanical energy final. So final mechanical energy minus the initial mechanical energy. So the final is here. We are having kinetic energy, which is given by a half mv squared. So now we take this as one particle. We add the masses, okay? 1800 plus 300. The velocity we don't know. It is the one that we are looking for, okay? Then plus the potential energy. What is the potential energy here? Potential energy is mgh. This is a half mv squared. This one here is mgh, okay? So the potential energy here, M, is again the same thing, okay? 1800 plus the 300. Then times the G, which is 10. Then the H. H is 50 sine alpha. Okay, so and sine of alpha, we know it. So do you see that what we are left with is just the velocity? Okay, now let's see what we are getting. Oh, there is also, this is final. Okay, final mechanical energy, then minus the initial. It is only the kinetic energy here. So it is a half, then times the sum of the masses plus 300. Then the velocity was 20, so squared. Now, what do we get here? 3,000 times 50, then minus, this is 6,000 plus 800 times the 50. That is 104,000. So I'll write 104,000. Then on the right here, what is this one simplified? 1800 plus 300, then divide by 2. That is 1050. So 1050 v squared. So what do we get here when we multiply? 2100, then times 10, that is another 0, then times 50, then times 0.05. That is 52500. 52500. And then here, already this one we have seen it as 1050, then times the 400 here. 1050 times 400, that is 420,000. Okay, then making V the subject, and here we are supposed to have a minus. Sorry for that, that's a minus. So V is going to be equal to the square root of 104,000 add 420,000. Remember, I've brought everything this side, okay? When this one crosses, it becomes a minus. So minus 52500. Then we divide by 1050. So what will be the V to three significant figures? Square root of 104,000 plus 420,000, then minus 52500. Then down here we have 1050. That is 2.19 and the rest of those figures, but to three significant figures, this will be 21.2. 21.2 meters per second, and that is that.